Good morning, students. Our today's topic in the topic of Newton's laws of motion is Newton's third law in the subject of mechanics A levels. So concentrate yourself. We are going to start now. The statement of this law is action and reaction are equal and opposite. This means that if a body A exerts a force on body B, then B exerts an equal force in the opposite direction on A. This is true whether the two bodies are in contact or are some distance apart, whether they are moving or are stationary. Consider, for example, a mass resting in a scale pen. This is the figure. The scale pen is exerting an upward force on the mass. So this is the reaction of the scale pen that is exerting on the mass, and the mass is exerting an equal force downward on the scale pen. So this is the reaction. Now consider two particles connected by a taut spring. Here is the taut string, and two bodies are connected with each other through a taut string. The objects are not in direct contact but exerts equal and opposite forces on each other by means of the equal tension in the string, which act inward at each other. So the taut string is here. So this body is putting a tension T on this body through a taut string, and this body is putting this tension on this body. Okay, this is true even if the string passes round a smooth body such as a pulley, which changes the direction of the string. So here you can see the two bodies are connected with each other through a string which is passing over a pulley. So such a pulley which changes the direction of the string. The tensions in the two portions of the string are the same. So tension will be same, and each portion exerts an inward pull at each other. So this body is pulling this body through this tension, and this body is pulling this body through this tension. So in each portion the tension at one end acts on the particle, and at the other end the tension acts on the pulley. All these tensions are equal. So when this is the tension in the string, the pulley is putting an equal tension in this portion of the string also. And if you look at this portion, this body is putting this tension in the string. So in reverse, the pulley will put an equal tension in this direction. If the string passes around a rough surface of the tensions in the different portions of the string are not equal, but the study of this situation is beyond the scope of this book. Here is a question that will make your concepts more clear about the Newton's third law of motion. So the statement of the question is, for each question copy the diagram, making your copy at least twice as big, and mark on it all the forces that are acting on each body. In question number 4, draw small blocks to represent the people. Use either a different color or different types. So come to the question now. Here is the question. All the forces are required to be plotted on this figure. So a load hanging from a beam which is supported at each end. So this is a load which is hanging from a beam. So the forces are required. So it is required that all the forces that are acting on each body. So concentrate now. So here are all the forces that are acting. So look now at this support. This will be the reaction of this support over here. This will be the reaction of this support, and here is a ladder that is putting on the support, so its weight will act downward. And here is a weight that is hanging from some support. So here is its weight that is acting downward, and in reaction there will be a tension in this string. But in reaction, the ladder will also put a reaction on it. So these are the forces which are acting in this figure. Here is question number 2. A mass on a rough table, so table is rough, is linked by a string. So here is the string to a mass hanging over the smooth edge. So the edge is smooth. So here is the second body that is hanging with this string. So again the requirement is draw all the forces. So here are all the forces. The weight of this object will act downward, and in reaction the table will put an equal reaction in the opposite direction. Because the table is rough, that's why friction will be there, and there will be tension in the string because the body is hanging with the string now. Okay, now this weight of body, like the weight of this body will act downward, and in reaction there will be a tension in this string, and because there is a smooth edge, so there will be no reaction in the string in opposite. So these are the forces in this figure. Here is another body. Another question. A mass B hangs by a string from another mass A. So this is mass B that hangs by a string from another mass A, which hangs from a fixed point. So that hangs from a fixed point. So this is the figure again, and the requirement is mark on it all the forces that is acting on each body. So here are all the forces. The weight of this body will act downward, and in return there will be a tension in this string, that is T2, that is equal to W2. But in return there will be a tension in downward direction also. At the same time the weight of this body will act downward, and in return there will be a equal reaction in upward direction also. These are all the forces in this figure. Here is question number 4. A man is in an elevator that is being drawn up by a cable. So this is the figure, and again the same requirement is there. Draw all the forces that is acting on each body. And here are all the forces. The weight of the weight W2 of the elevator, the full weight of the container will act downward, and there will be a tension in upward direction in the rope that is pulling the elevator up. Here is the W1 weight of the person who is standing in the elevator. Here is the reaction R because the elevator is pulling up. So here will be the reaction, and there will be a reaction R in downward direction. The person which is putting on the elevator.